Today we're going to do a lab, the purpose of which is to find the relationship between the horizontal position in time and the vertical position in time for something undergoing projectile motion. We know that the object is going to follow a parabolic path, right? We know it's going to look something like this. But what is the relationship between horizontal position and time and between vertical position and time? What are the materials we're going to use to perform this lab? The first thing you're going to use is a ball. That's going to be your projectile. So we're going to throw a ball at an angle up into the air as a projectile. It's going to follow a parabolic path, and you want to make sure that you don't have it going too far, but on the other hand, you want to make sure that you don't have it going too short of a distance as well. In the end, the next material that you're going to use, the next piece of material that you're going to use is your phone. You're going to video this. The reason we don't want it to go too far or not far enough is because we want it to cover most of your screen, but not more than your screen. Does that make sense? So you got the ball, which is your projectile, and you've got your phone, which you're going to use to video this thing. The only other piece of material that you use in order to perform the actual data collection is a meter stick. When you video this, you need to define for the video what a meter is. And otherwise, when you go to analyze this data, you're not going to know what the distances are. So I throw the ball up into the air. Hey, that's great. It took the entire screen. But is that 1 meter or is that 50 meters? We don't know unless we have a meter stick in the frame already so that we can define what a meter is. So somebody in the group is going to hold a meter stick up in the middle of the field of view of the camera. Somebody in your group is going to throw a ball following a parabolic path. You want to throw that ball more or less above the meter stick. Okay, if I hold the meter stick out 3 meters in front of where the ball is, we get what's called parallax error. You guys know that when you're looking at you're in the passenger seat of a car and you're looking at the speedometer and you think somebody's going a certain speed, the driver is going a certain speed, well, you know that that's not really right? You only know the true speed if you're looking at it straight on. If you're looking at it from an angle, we call it parallax error, and it gives you a distorted number for the speed of that car. Same thing will apply here if you keep that meter stick 3 meters in front of where the ball is or 2 meters behind where the ball is. You want to have the meter stick roughly underneath the path of the ball. It might not be possible to have it exactly underneath, but roughly underneath the path of the ball. Third person in the group is going to be the person with the camera videoing this. Now you want to keep this camera as still as possible, because if it shows movement, then the video, when you go to analyze the video, you're going to have trouble distinguishing between the movement of the camera and the movement of the ball itself. Those are your only 3 materials. What's the procedure? Well, we basically just described it. Right? You're going to set it up with a meter stick in the frame of view. You're going to throw the ball following a parabolic path so that the entire path of the ball is within the frame of the video. And you're going to video it from start to finish. That's it. Then you're going to go analyze it. How are we going to analyze it? Well, there's a software program that you're going to use called Tracker. And that software program is going to collect for you a number of pieces of data. It's going to collect for you the time. It's going to collect for you the horizontal position, and it's going to collect for you the vertical position. There's a mistake there in that column. The horizontal position and the vertical position. The instructions for that software are located in the little booklet that you guys have used before when using the SparkView app. Okay, it's on page 11, I believe, but it's in the table of contents. You'll see that. Once you've got your horizontal position and time, your vertical position and time, you're going to plot 2 graphs here. The first graph is going to be horizontal position and time. Don't forget to label your axes. Don't forget to label your title. The second one is going to be vertical position. Again, don't forget to label your axes. Don't forget to label your units. Don't forget to label your title. Title, by the way, is always y-axis versus x-axis, right? Horizontal position versus time. Vertical position versus time. Now, whatever shapes you get from those graphs, I want you to describe what they mean. Okay, describe the path of this ball, horizontal position and vertical position versus time, relating it back to the graph. So in other words, if we get a straight line here, what are we going to say? Well, we're going to say the vertical position is the vertical motion is constant velocity as illustrated by the straight line on vertical position versus time. Okay? If it's not a straight line, well then describe what that represents based on it not being a straight line. Okay, so your analysis includes two graphs, and it includes explaining what the shapes of those graphs mean. What comes next? Your conclusion. And your conclusion is essentially what you just said, relating the graphs to the shapes of the graphs, that is, to the motion of this object, both horizontal and vertical position versus time. Okay? So in other words, the horizontal position versus time graph shows us that it is constant velocity, or the horizontal position versus time graph shows us that it's acceleration, it's speeding up, and it's slowing down, or whatever the case may be. So describe the horizontal and vertical position as a function of time, and then justify how you know that. And then finally, you've got sources of error. Sources of error, as they always are. 2 or 3 good things, good sources of error, good things that could have led to error, and then suggestions for improvement for next time. Make sense? I'll talk about it in a second, okay? Just going to briefly talk about this software program. Okay, you've never used this before, and you're probably not going to be able to figure it out on your own. I promise you that if you follow the instructions to the letter in this booklet, you shouldn't have any problem. Once you get your data, though, okay, once you get your data, you're going to want to email it to all the members of your group. Got it? There's going to be a way to email it, and I'll talk about it in that booklet. Email it to all the members of your group, okay? You're going to email the data from all the members of your, email the video to all the members of your group, I should say, not the data. Email the video to all the members of your group. And then you're going to go on as a group on a computer, and then you're going to analyze the video according to those instructions. Okay, once you have that data and you're ready to plot the graph, then you're going to email the data to all the members of your group so everybody can plot those two graphs. All right?